Good morning, students. In this video, I am completely giving complex numbers concept. Okay, these formulas are very important for JE and examinations. Natural numbers n is equal to 1, 2, 3, so on. We know these formulas. Once check this. Whole numbers w equal to 0, 1, 2, 3, so on. Integers. Rational numbers. The numbers which are in the form of p by q, where p comma q belongs to I and q not equal to 0. Irrational numbers. The numbers which are not rational, which cannot be expressed in the form of p by q form, whose decimal part is non-terminating, non-repeating, but which may represent magnitude physical quantities. Example root 2, 5 power 1 by 3, pi e, so on. Real numbers. The set of rational and irrational number is called a real numbers. Okay, you can observe these. Imaginary number. Square root of a negative real number is an imaginary number while solving x square plus 1 equal to 0. Then x square equal to minus 1, x is equal to plus or minus root minus 1, which is an imaginary. So the quantity root minus 1 is denoted by I. It is called the iota. Iota, I is equal to root over minus 1. Integral power of iota. I is equal to root minus 1, I square is equal to minus 1. I cube is equal to I square into I, that is equal to I square value minus 1 into I. Therefore, answer is minus I. I power 4, that is equal to I square whole square, that is equal to minus 1 whole square, that is equal to plus 1. And I power 4 plus 1, that is equal to I power 4n into I, that is equal to 1 into I, therefore I. Okay. I power 4n plus 2, that is equal to minus 1. I power 4n plus 3, that is equal to minus I. I power 4n plus 4, that is equal to 1. Complex number. A real number in the form of z is equal to x plus iy. X is equal to real part, y is equal to imaginary part. If x equal to 0, it is purely imaginary part. If y equal to 0, purely real part. Z1 is equal to a plus ib, Z2 is equal to c plus id. Algebra of complex numbers. B2 complex numbers. Then addition. A plus ib plus c plus id. Write the values of real part and imaginary parts. Therefore, a plus c plus I into b plus d. Multiplication. A plus ib into c plus id. Here the value of I square is equal to minus 1. Therefore, real part ac minus bd plus I into ad plus bc. Division. A plus ib by c plus id. Rationalize here. Therefore, the answer is a plus bd by c square plus d square plus bc minus ad by c square plus d square. Here you can write the value of I also. Next. Additive inverse of z is minus z. Multiplicate inverse of z is 1 by z. Conjugate of a complex number. Z is equal to a plus ib is a complex number. Then z bar is equal to a minus ib. Properties of conjugate complex numbers. Z1, Z2 is equal to Z1 bar equal to Z2 bar. Z plus Z bar is equal to 2 real of Z. You can write here, that is equal to x plus iy plus x minus iy. Therefore, that is equal to 2x. Therefore, you can write 2 into real of Z. Next, Z minus Z bar, that is equal to 2i imaginary Z. Z bar whole bar is equal to Z. Z is equal to Z bar, therefore Z is equal to purely real. Z plus Z bar equal to 0, Z is purely imaginary. Z1 plus Z2 whole bar is equal to Z1 bar plus Z2 bar. Z1 by Z2 whole bar is equal to Z1 bar by Z2 bar. Modulus of a complex number. Z is equal to x plus iy, then mod Z is equal to root over x square plus y square. Properties of modulus of a complex number. Mod Z bar is equal to 0, then Z is equal to 0. Mod Z whole power n is equal to mod Z power n. That is equal to mod Z is equal to 1, then Z is unimodular. Mod Z is equal to mod Z bar is equal to minus Z is equal to minus Z bar modulus. Okay, you can these formulas also. Z1 mod Z1 into Z2 is equal to mod Z1 bar into mod Z1 into mod Z2. Okay, mod Z1 by Z2 bar is equal to mod Z1 by mod Z2. Amplitude or argument of a complex number. You can observe this diagram. This is the y, this is the z, x, and this is the mod z. Z is equal to x plus iy. Then amplitude of z is equal to tan inverse y by x. Note, The principal value of any complex number lies between minus pi less than theta less than or equal to pi. Principal value of argument. If theta lies in the first quadrant, then argument z is equal to theta. If theta lies in the second quadrant, this is the diagram, then argument z is equal to pi minus theta. If z lies in the third quadrant, argument z is equal to minus pi minus theta. If z lies in the quadrant 4, argument z is equal to minus theta. Properties of argument of a complex number. Argument of a plus ib is tan inverse b by a. Argument z1 into z2 is equal to argument z1 plus argument z2 plus 2k pi. K belongs to minus 1, 0, 1. Argument z1 by z2 is equal to argument z1 minus argument z2 plus 2k pi. Argument z power n is equal to n argument z plus 2k pi. K belongs to minus 1, 0, 1. Argument z bar is equal to 2k pi minus argument z. Representation of a complex number in various form. This is the real axis, this is the imaginary axis. This is the value of r. You can observe this diagram. Every complex number z is equal to x plus y, iy, can be represented by a point in the Cartesian plane known as complex plane, the order pair xy. OP is equal to mod z, that is equal to root over x square plus y square. Therefore, theta is equal to tan inverse y by x. Square root of a complex number. This formula is very, very important. Root a plus ib, that is equal to plus or minus 1 by root 2 root over mod z plus a. Mod z is equal to root over x square plus y square or root over a square plus b square. Okay. Plus I root over mod z minus a by z minus a for b greater than 0. Root a minus ib is equal to plus or minus 1 by root 2 root over mod z plus a minus I root over mod z minus a. Logarithm of a complex number. Z is equal to x plus iy. Be a complex number and in the polar form is z is equal to r into e power I theta. Then you can take logarithmic both sides, log x plus iy, log r into e power I theta. Log ab form, log ab is equal to log a plus log b to the base e. Therefore, log r plus log e power I theta. Log r plus I theta, that is equal to log root over x square plus y square plus I into tan inverse y by x, tan inverse y by x, or log z is equal to log mod z plus I into amplitude z. Okay, modulus amplitude form. Z is equal to r into cos theta plus I sin theta. Okay, this is also very, very important form. Here r is called as the magnitude and theta is the argument. Euler form. Z is equal to r into e power I theta. Here we can represent e power I theta is equal to cis theta, that is equal to cos theta plus I sin theta. Cube root of unity 1 comma omega square. The value of omega is equal to minus 1 plus I root 3 by 2. Omega square is equal to minus 1 minus I root 3 by 2. Properties of cube roots of unity. Omega cube equal to 1. 1 plus omega square equal to 0. Cube root of minus 1 equal to minus 1 minus omega square. And 1 plus x square is equal to x minus omega and x minus omega square. Note, 1 power r, omega power r plus omega power 2r. If the value is 3, the r is the multiple of 3. If answer is 0, r is not multiple of 3. Then the nth roots of unity. The roots of equation z power n minus 1 equal to 0 is called the nth roots of unity, denoted by 1 alpha, alpha square, so on, alpha power n minus 1. The value of z is equal to cis 2k pi by n, means cos 2k pi by n plus I sin 2k pi by n, where the k value is equal to 0, 1, 2, 3, so on, n minus 1. Properties of nth roots of unity. Sum of the nth roots of unity equal to 0. Product of the nth roots of unity is equal to minus 1 power n minus 1. The length of the side of polygon 2 sin pi by n. The area of the polygon is n by 2 sin 2 pi by n. These formulas are very, very important. Important formulas. Z is equal to cis theta, means cos theta plus I sin theta. Z plus 1 by z, 2 cos theta. You can observe x plus cos theta plus I sin theta, this is the z, and 1 cos theta minus I sin theta. Therefore, z plus 1 by z is equal to cos theta. Z minus 1 by z 2I sin theta. Z power n plus 1 by z power n is equal to 2 cos n theta. Z power n minus 1 by z power n is equal to 2I sin theta. X is equal to cis alpha, y is equal to cis beta, z is equal to cis gamma. Then the values, these values are very important. 1 by x plus 1 by y plus 1 by z equal to 0. xy plus yz plus zx equal to 0. x square plus y square plus z square equal to 0. x cube plus y cube plus z cube is equal to 3xyz. Complex number in coordinate geometry. The first one, distance formula. The distance between the 2 points AZ1 and BZ2 is AB is equal to mod Z2 minus Z1. Section formula. The point PZ divides the segment AB in the ratio m is to n. Internal division Z. mz2 plus nz1 by m plus n. External division mz2 minus nz1 by m minus n. Triangle of a complex plane. If the vertices ABC of a triangle represent the complex numbers z1, z2, z3 respectively, then centroid of the triangle ABC z1 plus z2 plus z3 by 3. In center of triangle ABC az1 plus bz2 plus cz3 by a plus b plus c. The value of a is equal to mod z2 minus z3. The value of b is equal to mod z3 minus z1. The value of c is equal to mod z1 minus z2. The area of triangle whose vertices are z, iz, z plus iz is half modulus z square. The area of triangle whose vertices are z, omega z plus z plus omega z is root 3 by 4 mod z square. Collinear points. If z1, z2, z3 are the collinear points, then z1 modulus z1, z1 bar 1, z2, z2 bar 1, z3, z3 bar 1 equal to 0. Argument z2 minus z1 is equal to argument z3 minus z1, and these three complex numbers are in AP. Straight line in a complex plane. General equation of line complex plane is a bar z plus az bar plus b equal to 0. The complex and real slope of the line a bar z plus az bar equal to k is minus a by a bar or minus real a by imaginary a. Two lines having the complex slopes mu1 and mu2 which are parallel, that implies mu1 equal to mu2 if perpendicular mu1 plus mu2 equal to 0. Circle in complex plane. Equation of circle is center z0 and radius r is mod z minus z0 equal to r. The general equation of a circle is z bar plus a z bar plus a bar z plus b equal to 0 if b is real number. The center of circle is a, then radius equal to root over mod a square minus b. Standard locus. Mod z minus z1 plus mod z minus z2 equal to k. It represents if k greater than modulus z1 minus z2, that is equal to ellipse. If k equal to z1 minus z2, it is a line segment. K less than modulus z1 minus z2, it is an empty set. And second condition, modulus z minus z1 minus modulus z minus z2 equal to k represents k less than modulus z1 minus z2, it represents a hyperbola. K equal to modulus z1 minus z2, it represents two rays. K greater than modulus z1 minus z2, it is an empty set. These formulas are very important. Once you can observe and you can revision this, these are very important to you. Thank you for watching. Like, share and subscribe.